Alright, welcome to Chapter 5. This is natural log, function, and differentiation. If you notice, the natural log of x is equal to this function. If we take the second fundamental theorem of calculus, you get the derivative is equal to 1 over x. So that really is the derivative of ln of x through all this stuff. Some things to know about the natural log function. The properties, here's the domain, here's the range, there's the graph. It's increasing, it's monotonically increasing, it's 1 to 1, and it's concave down. I'm reminding you that the ln of e is equal to 1, and if you don't see the base, you know the base of ln is e. Going down, derivative of natural logs. When you derive that, I just told you in the beginning that the derivative of natural log is 1 over x. All right. However, x has to be greater than 0. The derivative of the natural log of u, meaning u being an expression, is just going to be u prime over u. So you take the derivative, you put it on top, you take u, you put it on the bottom. Done. Those two formulas are waiting for you to be used. So let's play. Let's play a little bit. All right, we got some examples here for you. You knew that was coming. So here we go. If I follow my rule, it's going to be 2x, and the derivative of the inside, or the expression, goes up top. So that's 2. You can cancel the 2's, and that guy is 1 over x. Right now, you guys are saying this is the easiest thing ever, I hope. This one turns out to be, the derivative of this turns out to be x squared plus 1. On the bottom, on top, 2x. Done. You gotta love this. This is piece of cake, as they say, upside down. This one you gotta use a little product rule action. So derivative is gonna be first times derivative of second. Derivative of second is 1 over x plus second times derivative of first, and you're gonna get 1 plus, and the derivative of first is 1, so it's gonna be 1 plus log of x, or natural log of x. That's it. This one's a chain rule. Okay, so we're going to set u equal to ln of x. Du is 1 over x. So my problem becomes u cubed. That's going to be 3u squared times du. Go replace everything back. 3 times the ln of x quantity squared times the 1 over x, and I'll just put x underneath. There you go. So that is a chain rule, CR, chain rule, PR, product rule. That's it with derivatives. I'm going to bring you back, okay, bring you back to some properties of logs that you'll use when you go ahead and do these derivatives, because sometimes they can look a little different. Here's some logarithmic properties. The log of 1 is 0. All right. The log of AB, remember the multiplication could be broken up. So if you get 2 expressions there, you can break it up to the log of A, natural log of A, plus the natural log of B, and then take derivatives then. This one, when you have a power in there, you can bring the power out in front. So it could be n, the natural log of A to the n is the same as n times the natural log of a. And the last one is the quotients, where you have the natural log of a over b is equal to the natural log of a minus natural log of b. Remember, natural log and exponential functions are inverses of each other. They undo each other. Next, let's do some let's practice that a little bit. This is non-calculus stuff, which you should be excited about. Let's do 1 ln of xy over z. Now I'm going to rewrite that as a sum or difference multiple logs. So this is going to be the natural log of x plus the natural log of y, all minus the natural log of z. Remember, multiplication is plus, division is minus, just like you would do with powers. Number 2, the natural log of z times z minus 1 squared. Well, now I'm going to use the multiplication property, and that's going to be ln of z plus ln of z minus 1 squared, and now I'm going to bring the 2 out in front. So then I have a problem that looks like this. Now if I needed to take the derivative or something, now it becomes a much easier derivative. I take the derivative of this, then taking the derivative of this. So that's why this is making its way into here, all right? To be easy on derivatives. Let's look at 3. I'll do the natural log of 3e squared. That's going to be, let's move it down a little bit. This is going to be the natural log of 3 plus 2 times the natural log of e. This guy is equivalent to 1. So my answer will be 2 plus the natural log of 3. All right? Natural log of e, base e, is 1. Done. I put the 2 out in front. I didn't show you the 2 here, and I'm moving out in front. Did it all one step. Now I have over here, rewrite as a log of a single quantity. So now let's go the other way. So this would be a minus. So there's division. This guy on top, this guy on the bottom, and then it's the natural log. All right, well, not bad. Look at this one. The natural log, the 2 would come up by the 3. So that'd be 3 squared. And then on the bottom, it would be x squared plus 1 to the 1/2 power, because I'd bring the 1/2 back over here. But guess what? 1/2 power is square root, so I would write it like that. That's how I would write it. Any more? No, I'm good there. I think you're good there. Let's go on. Derivative examples. Here we go. So now we're combining the derivative and rewriting the logs. So let's see what we have here. So I'll probably rewrite this as the natural log, if I can, 1/2 the natural log of x squared minus 4. All right. Well, the 1/2 is going to stay, and now we're going to do this. X squared minus 4 is going to be x squared minus 4, 2x on top. Cancel the 2's. I'm left with just x over x squared minus 4. So I use the property of logs to break it up, and then I go ahead and do the derivative. Let's look at this one. Holy cow. I'm going to do probably a u substitution here. All right, I'm going to say u equals the natural log of x, and u prime or du equals 1 over x. So I am going to do the natural log of u. Natural log of u is u prime. So u is ln of x, u prime is 1 over x. So this turns out to be, you join with your friends, and this becomes 1 over x ln of x. Good? Questions? Okay. Let's go large. Absolute value gives you the same thing. So it doesn't matter. In the secant world, okay, my example is let's do secant plus tangent. Absolute value. So if I say u equal to secant x plus tangent x, du is going to be secant x tangent x. That's the derivative of that guy, and the derivative of tangent is secant squared. Working hard here. Right, so that's its derivative. So what we're going to have is secant plus, I forgot the x. It's not that big of a deal, but I forgot the x. Secant x plus tangent x, and the du over it, if I set this guy equal to u. So du is going to be secant x, I'll factor it. Then I'll have tangent x plus secant x, because I'll factor a secant from each one. So I'm going to get these going out, and I'm going to be left with secant of x. There it is. Secant of x. Not too bad. I just did this problem. So let's bag this one. All right, if I did something here, I'll make one up. If I did y equals the natural log of sine x, then this would be sine x cosine x. So this would be this would be cotangent of x. All right, that's what the natural log does. Are there any questions? Why don't we try a couple? Not that many. Let's try a couple. For homework, why don't you just try 20, 30, 36. Try those three. We'll do the rest in class. All right, but these should be pretty good. So this is on page 331. All right, that is it. That's the derivative of tangent. You'll be seeing the integration of tangent. Wow, I misspoke. That's the derivative of the natural log, and you'll be seeing the integral of the natural log next, probably in the next section. All right, thanks. See you tomorrow.